Hello everyone and welcome to another SurfaceLab tutorial. My name is Julia and today I would like to show you how to do MVSA on spectra. For our experiment we have prepared 3 commercially available highlighters in different colors on a substrate and acquired spectra with 5 repetitions on each color. After the analysis you will end up with 15 data sets and hundreds of mass intervals. The goal is to find mass intervals to distinguish between the different highlighter dyes, and PCA will help us to do that. MVSA on spectra requires handling of multiple data sets at a time. Before you can start the MVSA calculation, some preconditions have to be fulfilled. To prepare the data for MVSA routine, load all analysis files into the data list. Copy all spectra data views into a new analysis and make sure that all spectra are calibrated in the same way. Then generate a peak list containing a significant fraction of the measured intensity of all spectra. This is done very quickly with the new global peak list feature. Apply the peak list to all spectra data views, and now you can run the MVSA routine. Let me show you how this is done in our software. First, load all analysis files into the data list and duplicate all spectra views into a new IDAX file. The best procedure is to use the function duplicate into new storage from the context menu of the data list. Make sure to calibrate all spectra the same way. The best procedure is to calibrate one example spectrum and use the function apply mass calibration to all spectra from the main menu. Use the global peak list tool to create a mass interval list which assembles the measured intensity of all spectra. Run an auto peak search on all spectra and generate a unified peak list. Apply this list to all spectra. Open the MVSA calculation tab in order to address the calculation options and select the spectra to be taken into account. Run the calculation and have a look at the eigenvalue plot to decide how many factors or components you would like to include. The result of the PCA calculation are the scores and loadings. The scores give the relationship between the samples, which means the data views, and tell the amount of each sample on the factor axis. The loadings describe how the mass intervals relate to the factors. This often provides chemical insight into the sample differences. If 2 factors are selected in the toolbar, the spectra program will display the corresponding scatter plots of the loadings and scores. The spread of samples in the scores plot can also give an idea of the reproducibility of the samples in the dataset. If all the samples are tightly grouped together, it means the samples are spectrally similar. In this example, factor 1 can separate the red highlighter from the blue and the yellow one, and factor 2 can separate between the yellow and the blue highlighter. As you can see, PCA is capable to distinguish between the different highlighter dyes and provides information about the respective characteristic secondary ions. I hope you enjoyed this video. Have some fun playing around with our new MVSA feature. My name is Julia. Thank you for watching and goodbye.